Alright, HVAC people!
Boilers. I was out at Brazos County Expo yesterday with some of your guys looking at the X-Verses that they're installing there. And that would be on the Versa IC side. So if we could delve into that in depth, that could pretty much be its own class for a future date if we start to see the need for that. TDLR codes, carbon monoxide, we're definitely going to talk about that because that's extremely important. Whenever you're dealing with boilers, understanding the TDLR laws when it deals to ventilation and combustion air and carbon monoxide. Just some of the information on the building. We are a family-run company. You can see these guys all day long in the office. We do have factory-trained technicians here in Houston and in Austin. We have an office in Austin, and we have a brand new office in College Station. I didn't know about that till last week. So we do have a team out there because we do a lot of work at Texas A&M and at Prairie View A&M. So we have a new office out there. We do factory startups. Y'all probably, I don't know if any of y'all been out on startups and met Bo or Billy or Peter. Now myself, I'm going to be starting, I've already started doing startups. On our trucks, if you'll see our trucks, like Jason's truck outside, you'll see the WW logo, but you won't see phone numbers. The reason that is we're not here to take anybody's customer. That's your customer. That's your customer. If you call a Wilbanks out to give you a hand on a startup or a boiler situation, we're there to help you. We don't want your customer calling us, so we want them to deal directly with you. And if you need us, you call us. Okay? We don't want any of y'all feel threatened whenever a Wilbanks truck rolls up. We're here to help y'all. Just like Matt said, it's Wilbanks contractor support. Okay? We do pre-pipe meetings. I've done them. I'll go out and sit on new construction sites or new job sites. If they're doing a retrofit, I'll go out and sit with you. If the piping's done right, we get the information. We'll look over it and make sure that it's correct. It is. We're good to go. So, also warranty issues. You'll be dealing with us on any HVAC warranty issues or while McLean, first, whichever boilers you may install that's ours. And then troubleshooting. Jason and I will help on troubleshooting any time of the day or night. You can call us directly. We'll try and do it over the phone and help you out as best we can before we have to send a truck out. So that's one of the things that we will offer you. We do have rental boilers. Keep that in mind. If you have a customer that goes down in the middle of the night, we've got rental boilers. I drive a 3/4 ton truck. I hook up to it and drag it out to you. It's a plug and play. The flanges are on the outside. They're on the other side. I got two 100-foot stainless steel braided hoses for hot water and another 100-footer for gas. It's 110. Plug an extension cord to it, turn the boiler on. It's a 1.5 million BTU boiler inside of there, so we can put it on location for you. Some of the things we can do, some of the drawings that we offer, just we do have our own CAD and Revits team that can do drawings for you if you need them. I'll go out and do a takeoff on the system. I'll get all the information and we'll have them drawn up for you. If that's something you might need. Just some of the information of things that we can get, anything in a boiler room that you guys need, from a thermometer to a pump to a tank to a boiler. These are just some of the things that we have. Some of the manufacturers. One thing about Raypack, it's an interesting deal. Wilbanks will be 42 years old this year. Raypack and Wilbanks will be 42 years old together. We've been with Raypack they've been with us since day one. If y'all know anything about the boiler industry around town, there's been a lot of companies doing this. Between Lars and Lochinvar and all those, there's been companies passed on, switching. We haven't. Jason and I were just there a couple months ago, and they know us extremely well, so it's been a good relationship. Different types of heaters and boilers. You got an electric heater. These are electric on demand, kind of like your Renais and your Takagis and stuff in your house where you put an on-demand heater, a tankless. That's these right here. You got an electric. They're starting to put a lot of these in the schools in the valley. They're putting them in the bathrooms. Instead of having a central plant where they have a boiler and a whole bunch of piping running through the school, they're putting these right here in each of the bathrooms under the sink. It's an electric, on-demand hot water heater. It saves them money on piping and installation and space. Mainly space. They don't have to build a big extra room for a central plant in a school. Then you got your your all-in-one, kind of your GN 100, 200. You got the burner at the bottom. You got a storage tank, your inlet and outlet, and then your your flue comes out of the top. This is your standard domestic hot water system. You got a boiler, you got a storage tank, an expansion tank, and the only job of that boiler is to heat the water in that tank. That's a domestic water setup. We'll go over that a little bit more. As far as the heat exchangers, this is a fire tube heat exchanger right here, stainless steel. You got your sectionals, aluminum sectional and cast iron sectional. You're going to see these mainly in your hydronic systems. Okay, the reason why is condensate. And return temperatures of the water have everything to do with how a system operates, whether it's condensing, non-condensing. We're going to go over that here in a little bit too. You got a vertical copper fin tube. You got a horizontal copper fin tube. You see that little plug right there? Keep that in mind. I'm going to come back to that in a minute. There's a specific reason for that little plug. You got your Scotch Marine boilers. These are your high mass boilers. If you have an application where you use a lot of hot water, that's going to be your Scotch Marine. And then you got a flex tube boiler here. These things are old and you don't see a whole lot of them anymore. The ones that are out there still, they're being phased out and pulled out. The ones that you're mainly going to be dealing with here is your stainless steel. This is a fire tube. This is the lowest pressure drop of pretty much any boiler out there. It's about a 5 psi drop. On the other hand, this is one of the highest head pressures across the heat exchanger. This is a Giannone design. We don't like it because of these square tubes. It has area where scale can build up. And because of the pressure drop, you have to have a lot of pump with it. This one, you can get away, there's multiple, depending on the system, you can get away with smaller pumps. This one has a lot of pumping needs. These are really good because they're sectional. A lot of people don't like cast aluminum. Cast aluminum has 12 times the heat transfer than stainless steel. So thermal wise, it's extremely good, but it's also costly. The other thing too is when you have an aluminum boiler and you have metal piping, any metal that comes off of that piping and gets into that aluminum, you get dissimilar metal corrosion. Okay, it causes corrosion. So it's kind of a tricky situation. Cast iron, and it's like a workhorse. They're not good for corrosion, but because they're so heavy duty, they can withstand it a long period of time. And then this is also another high head application. This is your your vertical copper fin 4-pass tube right here. So condensing heat exchangers, you're looking at cast aluminum, stainless steel, and cast iron, even though it's not corrosion resistant. So what is a condensing boiler? It's a water heater fueled by gas or oil. They achieve high efficiency. It says typically greater than 90, but nowadays it is greater than 90%. But it does it by condensing the water vapor in the exhaust gases, so recovering its latent heat of vaporization, which would otherwise just go out the stack. So we're trying to recover as much heat out of this boiler as we can. Okay. Now the other one, that's the condensed vapor leaves the system via drain by liquid form. This is what we're talking about. You got your main burner and you got your heat exchanger. Now most of the time you would have a stack up here, so whenever that hot air goes across that heat exchanger and warms the water, it just goes straight out the stack. Instead, you're going to turn that exhaust gases and we're going to run it across another heat exchanger, an inlet heat exchanger. So we're extracting as much of that heat out of that exhaust gases as we can. Now at 126 degrees, that exhaust gases starts forming a liquid called condensate. Right here. And there's a condensate drain, and then what's left of the exhaust gases will go out the flue. Now that flue gas is a lot cooler than it would be on just a regular domestic hot water boiler that's going over one heat exchanger and going out. This is actually a lot cooler. The problem with this, and this is why we talk about the heat exchangers, that condensate is extremely aggressive. It is acidic. It's high efficiency condensing boilers and hot water heat extract. Additional BTUs form the water vapor in the flue gas. It starts below 130. We'll say about 126. Here's the key. The acidic level of condensate measured on a pH scale. Scale is 0 and 14. 7 is neutral. pH is between 2.9 and 4. So it's on the acidic side. I've seen condensate eat boilers off their foundations. On a non-condensing boiler that's not designed for it, it'll eat it up within months. So it's extremely aggressive. So on condensing boilers, whenever that drain comes off of that boiler, there has to be a neutralizer or a pH conditioner, because in California they told us neutralizer was incorrect terminology, because unless you have somebody testing it to see that it's at 7, it's not neutral. So it's a pH conditioner. If you don't do that, you're going to make every plumber in that facility mad, because when that condensate goes to that drain, it's not only going to eat the drain up, it's going to eat the concrete around the drain. So they're going to have to bust it all up and repair it. I've seen that. So it's extremely important that you do that, that you have to neutralize it. On a non-condensing, you can use pretty much anything. The reason that the copper fin is the highest, it has the highest heat transfer, the reason it's used the most is it's the least expensive. You can put a cast iron or a stainless on there. You're not worried about condensate, because the temperatures are much higher. You're not going to condensate. A non-condensing boiler is a single heat exchanger chamber where the hot gases from the burner pass through the heat pass the heat through to the water within the walls of the exchanger before exiting the flue. This is key. That is extremely key. The return temperatures have to remain above 126 degrees. As soon as it drops, that boiler starts to condense and you'll eat it up. Can a non-condensing boiler be used in a hydronic situation? Yes. There's always a but. It needs help. These are thermostatic 3-way mixing valves. I don't know if you guys ever seen these. They're a wax ring. They work off of temperature. Okay? And what they're designed to do is the water coming in, if it's warm enough, it'll bypass this. Okay? If the water coming into the boiler is too cold, it will actually let water from the boiler back into the boiler to heat the water. Oh, yes, sir.
I just want to back you up just a little bit.
Sure.
These gentlemen are used to condensate all day.
Okay, good.
So, but I want a little clarification. If you could explain why these condensing boilers are so corrosive, acidic,
Yes.
as to why they're causing this damage when we deal with condensate all day long, and what you're describing takes years to accomplish. I was wondering if you could go a little bit into the flue makeup as it condenses, what type of gases we're dealing with, so when they corrode. I'm used to a Scotch Marine.
Okay.
Non-condensing, but I can see what it does, like if you want to get to a carbonic acid situation,
That's it.
if you don't have good tuning, what it does to a brick and mortar situation,
Yeah.
what it can do to a steel stack, especially at
Yeah.
the welds, and then why stainless is so expensive. Throw all that away. If you could just explain to them about why that flue is different, condensed,
Yep.
to everything that they know.
Okay. Now I'm going to get to that here. That's later on. I've got all the venting. When we get into the venting part, I'm going to break all the acids down.
Okay.
I'll have that. This here is key whenever you're talking about non-condensing. And I know you guys deal mostly in condensing. So domestic hot water is pretty much out, right? Y'all don't deal with domestic at all?
We may be getting into it. It's hard, sometimes
Sure.
you come across a boiler and you realize it is a glorified hot water heater, or they're
Basically.
using a boiler with the side discharge heat exchanger as part of their hot
Indirect,
water.
direct, indirect?
Correct.
Gotcha.
So, I don't wanna say no.
Okay.
I'm tempted to say no, but I would be wrong.
I
if
understand,
did.
I understand. Yeah, especially if you're maybe expanding or broadening. And like I said, you never know what you're gonna come across. You're working on one type and they say, hey, well, we got this over here. Maybe you can look at it as well. So in a non-condensing situation, and this is in a hydronic as well, since we're talking about hydronic, you can use a non-condensing boiler in a hydronic situation, but it has to be assisted because of the condensate factor, all right? A non-condensing boiler, you don't want it to condense, so you would do an installation like this on a 3-way valve. The thermostatic mixing valves we don't like. They fail. That's just the way it is. They're a wax ring, a mechanical type valve. There's no indication of it failing, other than the fact that the boiler high limit temperature goes off, or you're showing signs of condensing. So if it fails in the closed position, and it doesn't let water reroute back to the boiler, your incoming temperatures are going to drop and your boiler is going to condense. And you're not going to know that until it's too late, or unless you see condensate running out of the boiler, or your customer doesn't catch it. it's gonna eat those tubes up. If it fails in the other way, if it fails in the open position, it's gonna reroute all the boiler from, hot water from the boiler back to it, and eventually you're gonna hit your high limit temperature, or your high limit switch, your manual high limit switch. And it's gonna trip the boiler. And then it's gonna keep tripping. It's gonna keep tripping because there's no indication to it. So what we do is we put in a cold water start. A cold water start is a motorized three-way valve that will keep that inlet temperature above 126 degrees, and it's monitored. You know, all the ray packs are wired for it. It's just 3 wires, put the valve in, and it's already there. So that's the key thing on a non-condensing boiler in a hydronic situation. It can be done. We've done it at churches where there's building heat. They didn't have the money to go and buy an MVB or an X-Therm or an X-Verse, the high dollar condensing modulating boilers. So they went with the Delta Limiteds, the non-condensing, and all we did was put in the motorized ball valves. It saved them money, but it got the job done. This is a 3-year-old heat exchanger that it's a non-condensing in a condensing situation. This heat exchanger is designed for a small amount of condensate, but it's not a true condensing boiler. But it's got weep holes in it so that any condensate forms goes into the stack and out. It's evaporated. This one, the hole's plugged up because of the white rust, and it started eating the boiler up. Then you get to this right here. This is extreme, okay? When you have a non-condensing boiler in a condensing situation, that's exactly what's gonna happen. It's gonna eat it pretty much. And believe it or not, whenever a boiler fires and it has a stack to remove the heat, the reason that is these burners are made of stainless steel alloy. Believe it or not, they don't handle heat that well, and that's direct heat. So there's a lift off. You have a 1/4 inch lift off on these burners. That's why the air and gas is so important whenever you're setting combustion, to make sure that that flame is at a proper distance off of that burner. This is your high-low gas settings. Okay, there's your little setting right, you check it right here. This is where you would do your adjustments. We set these boilers at 100%. We bring them up, run them at 100% because modulation, as it starts dropping down, it's all linear. You don't know if you're going to run at 30%. You know you're going to run at 100 because it's going to come up and run at 100. And as it starts meeting that loop temperature, it starts dropping off and starts modulating down to maintain that temperature. So if you set the air and the gas at 100%, you're going to be just fine because it's all linear. Here's the ratios we talked about, 7 to 10 inches. Your air pressure, -4.1, your manifold 5.9. And again, it all varies on the manufacturer. So if you have copies of the O&M manual, they will tell you inside of there the exact numbers that they're looking for. Just to go over a little bit of domestic, since y'all don't do a lot of it, but you could in the future. It's just a heat transfer process for heating water for cooking, cleaning, showers, what have you. This is your typical setup that you're going to see. There's atmospheric boilers pretty much gone. You can't have them in the state of Texas, except in the valley, and it's 4 million BTUs or larger. So in the city of Houston or in this area, the southeast Texas, you won't see new atmospherics because they're not allowed anymore. So what you're going to see is a boiler with a storage tank thermostat. That boiler's job, the only job it has is to heat the water in that tank. Okay. Everything out of the boiler room is separate from this right here. You got an expansion tank. You're going to have a circulating pump. Now, a couple of key things to remember on domestics that you don't ever want to see. That right there is your return water from your system. Also, it's your city water makeup. You don't want that water going directly to the boiler first. That must always go to the tank first. Reason being is you don't want to lower that water temperature coming into the boiler. This is a non-condensing application. You always want to maintain that water above 126 degrees so that this boiler doesn't sweat. If you start putting this colder water into the boiler first, you take a chance on doing that. Plus, we have about 9 to 10 grains of hardness in the water here in the city of Houston. To equate that, if you take a gallon of water and you take 10 bare aspirin and put it in that water and shake it up, that's how much hardness is in the water. And now it's soluble. You don't see it, but you feel it. Whenever you take a shower and you're all squeaky clean, that's calcium. So you don't want that going directly into the boiler first because it looks for two things. It looks for a heat source, and it looks for a pressure drop. It's exactly what you have in that boiler. Because you're putting water in that boiler, you're heating it up, and then you're rerouting it back out of the boiler. And at the end of that heat exchanger, you get a pressure drop. Calcium will start falling out, and it's quick. It's very aggressive. Okay, calcium is nature's insulator. We're not going to go over a lot of the water chemistry in here, but here's how next time you cook breakfast in the morning and you cook eggs, take half of that eggshell and put your finger in it. Take a lighter and light it and put it right underneath your finger. See how long it takes to feel that heat. Now imagine that's calcium. An eggshell's calcium. So imagine that calcium layer being on that tube, and that tube's job is to heat that water in that boiler. And you've got that layer of calcium through there. How much more gas, how much more heat do you have to have? So your usage goes up in gas and your efficiency goes down, and your customer starts seeing it on their gas bill. So it's extremely important. That's why we also push softeners. We talk about softeners all the time. We try and make people understand that softener is going to make longevity on that boiler. You're going to get your money back. Your return on investment will happen with a softener. Whenever you're talking about that being a 12-year, 10-year, 12-year boiler versus a 15, 18, or 20-year boiler. You got your flow switch, your pressure relief valve, and the thermostat. This thermostat controls that boiler. We like to maintain these tanks at 140 degrees. Domestic water, you don't want it to be below 135 degrees. The reason that is Legionella. I'm sure you guys have had to deal with Legionella in cooling towers and other types of places where you can get it right here too. And it's really bothersome really troublesome whenever you get it in or you're worried about it with assisted living, VA homes, schools, things like that, because it affects the elderly and children more than it would affect you. It's going to make you sick. Cold symptoms, but it can kill the elderly. It's a waterborne bacteria that as soon as you turn the water on, it becomes airborne. Okay, so that's why we want to maintain that tank 140 degrees. Thermometers, gauges, you guys work with them all the time on chillers. You got chillers and stuff reading your condenser pressures, your cooler pressures and things like that. No different with these boilers. We try and tell people to put gauges and thermometers on the inlets and outlets, because they'll tell you what's going on inside that boiler. Like with Jason and I in the Navy, we couldn't see inside of our turbines or our condensers or our evaporators and stuff. Those gauges told us. That's why we monitored them every hour, to make sure that we knew what was going on inside that equipment. No different here. Plus, if you're starting to deal with domestic hot water, you're going to run into this problem. They're going to call you and say, my boiler's bad, or my boiler's not working right. What's wrong? Well, building 3 has no hot water. What about building 1 and 2? Oh, they're fine. Building 3 just has no hot water, but the boiler's bad. So if you've got a thermometer on top of that tank and you walk out there and that thermometer's 140 degrees, you let them know it's not my boiler. It's something downrange. Because all that boiler's doing is heating that tank. If you've got good hot water there, your boiler's fine. We run into that all the time. They tell us there's a problem with the boiler. It's easy to blame. I don't want to look at their other problems out on the property. Combustion exhaust venting. This is a key whenever you're talking about hydronic, between hydronic and domestic. Exhaust gas temperatures are everything. Category 1, what you see in your hydronic systems and what y'all deal with is going to be category 1. Okay, you're going to see stainless steel. You may see PVC, CPVC, PVDF, what have you. Everything follows the NFPA 54, the National Fuel Gas Code. Okay? On your domestic systems, you'll see category, say category 4 on your hydronics, your stainless steel. Category 1 is what you're going to see on domestics. That's a B vent. That's a sheet metal type stack. You'll never see that on a hydronic system because of the condensate. So this is just some things on the, whenever you're doing any type of combustion air coming into a building for a boiler, if you're doing horizontal, it has to be category 3 and it has to be at least 12 inches off of the ground. They did that for snow. Here we do it for flood water. Same thing with off of the roof. If you're coming from the roof down to the boiler for combustion air, it has to be 12 inches off of the deck And it has to be a minimum of 36 inches away from the stack outlet of the boiler so that you don't get recirculating flue gases. Anything horizontal, okay? Any type of vent horizontal coming in or going out has to be category 3. The reason that is that whenever you start turning these sideways, if that stack gas goes up and turns, the heat of that stack gas rises to the top of it. The bottom of that vent's going to cool. That's where you're going to condense. That's why you have to have these drains right here. And it has to be category 3, at least category 3, because that's stainless. That's corrosion resistant. I'm going to go here. Here's some of the rules, the common rules in venting. A lot of these get overlooked whenever you're dealing with engineers. The 75-25 rule, 75% vertical and only 25% horizontal. That is NFPA rules. That's not anybody specific. That's the government saying that. You know, 75-25. Any vertical stack 25 feet or higher requires an assisted fan or a barometric dampener. The reason that is you start getting that stack higher and higher, and it doesn't have any type of assist to pull that air out of there, to pull those stack gases out. You're going to stack them in that stack. And eventually, it's going to be like gunpowder. You're going to stack them, and eventually it's going to light. You can ask Bo. If y'all ever meet Bo, he shot one of our cones off the top of Alvin ISD's newest school. He shot it all the way out and all the way across the parking lot and landed between 2 brand new trucks. So, and then it scared him. He still talks about it. You're going to know if that goes. But remember, 25 feet or higher, it needs a dampener or a fan. Here's something that I guarantee a lot of people don't know. A 90-degree elbow adds 10 feet to a stack. So if you come off of that boiler, come off of it 2 feet and you turn it over, you just went 12 feet. Okay, and then you turn it back up, you just went 22 feet. So 90s are 10 feet, 45s are 5 feet. So when you start adding 90s and 45s, you're adding a lot of stack to it real quick. This is where you're going to start getting into the fans, the journaling fans, either pulling the exhaust out or pushing it out. More likely going to be pulling it with fans or barometric dampener. Okay. Refer to the NFPA 54 for any flue gas issues. All B vent. If you're doing domestic water and B vent, we recommend that they're double wall for burn protection. If you touch a single wall, that stack's going to be close to 300 degrees. You touch a single wall, it's going to burn you instantly. So we like to have that air gap. Flue gas condensate is a chemical reaction. The element are carbon monoxide, carbon dioxide, nitric acid, along with carbonic acid. Like what he's talking about earlier. Acid is acid that all gases, it all fumes. Okay, whether it's in a drum or it's in a stack. If you open a drum of sulfuric acid or muriatic acid or nitric acid, any of those, we've dealt with all of them in water treatment. You leave that drum open, you're going to come back a month later, there's going to be corrosion and rust all over that room because of gassing. No different inside of a vent. If that vent is not properly done, that condensate is going to eat it completely up. You get white rust on some of them. With stainless steel, you're not dealing with it. CPVC, and again, you can do this on a condensing boiler. You can use plastics because you're talking about a stack temperature of 100 degrees, 110 degrees. Schedule 40 PVC is what, rated for 140 degrees? So you're talking about a stack temperature that's never going to get there. So you can use that, and it's a good protectant against the condensate. That's why certain boilers require non-corrosive material for venting. Now, on your big Scotch Marine boilers, did you have an economizer? You do economizer on any of those Scotch Marines?
In one of my locations, yes.
Okay, we had a problem with mine. The stacked gas is eating the economizers up. We thought it was an oxygen problem in the feed water with your sulfite, feeding your sulfite. We thought that was the problem. It was actually a stack problem. There was something with the material in our economizers that just kept getting eat up. And then, come to find out, the mixtures, we had the settings. We had a guy come out and reset our boiler, and we were burning We were burning rich. We were burning rich or lean, one of those. We had it said the combustion was not right. So that's what's important about any boiler, having the combustion set right. Because Jason and I do stack gas analyzers. Y'all don't have stack gas analyzers, do you?
We do.
Oh, you do have them? Okay, good. Man, that's, yeah, you'd be surprised who people running around there playing with boilers don't have it. So.
We do it for a lot of our equipment that will have like a gas, maybe a multi-stage or modulating gas burner.
Correct.
Going through one of our units.
Gotcha.
So we have to, on our startups, we have to do burner tuning.
Correct.
Essentially, is really what we have to do to get our ratios right and make sure that we match. So we're not, burning too lean.
Exactly.
Too hot.
Yep.
Or if we're burning too rich and our emissions are output.
Exactly.
So we use our analyzers for that, but essentially that's what they are, stack analyzers.
Okay. See, we use our combustion analyzer. We're more combustion, because what we're gonna be dealing with is if we don't have the combustion set right, we're gonna destroy the burners and we're gonna soot the heat exchangers. You can soot the heat exchangers in these boilers to where you won't get the heat flowing through them. It can be, catastrophic. I've got a picture in here of one where they didn't set anything. They put a brand new regulator in. It was a plumbing company, if that tells you anything. Put a brand new gas regulator in, didn't set the gas pressures, didn't set the burners, and they turned it on and left, and then 3 weeks later it destroyed the whole boiler. I'm surprised they didn't burn the apartment complex down. Be it modulating. I've got this set up on here for on the horizontal copper fin because they're easier to see inside of. They're easier to see all the components. On any of the ray packs, you're going to see these lights. You've got your power light, your copper heat, your burner light, and then your service light. It doesn't matter if it's a stainless steel modulating or a copper fin tube. All of these lights are going to be on there. The service light's the one that's going to blink at you if there's something wrong. The safety circuit starts out with the pump. A lot of times you won't hear the pumps running. Okay, you'll walk into a boiler room and first you're going to hear is the fan. But this pump comes on, that flow switch, 22 gallons a minute is the minimum. Okay, I don't know, y'all ever see paddle type flow switches in chill water? I know has them, but yeah, that's them. Then the second thing that's going to happen is that fan's going to come on. This is what you're normally going to hear when you walk into a boiler room. Because that fan comes on and starts, those panels will rattle. You may not hear the pump running, but this fan you're going to hear. Now this is a pressurized chamber on these boilers right here. Okay, it's got a gasket on it. There's a larger panel, and then there's 3 small panels for your access to your hot surface igniters and your flame sensors. This fan comes on and pressurizes it. This is what I was talking about earlier, is an air proving switch. This is a positive pressure switch that tells the boiler, I've got air, I've got positive pressure, 1.4 inches of water column is what you're looking for on an air proving switch in this type of boiler. Now locking bar is a little different. I know theirs is 1.3. Again, we look at the O&M manuals of any type of boiler you're working on. They'll give you these numbers. Okay? The ignition cycle happens. This again, the hot surface igniter. These things are carbon. Keep in mind this is ceramic. Ceramic's one of the hardest known substances on the earth, right? When you reach down on those screws right there, you'll snap those ears clean off. I learned it the hard way. I used a drill to zip it down and pow. So you snap those, it may cause a break in here where it won't work properly, or it'll fall over. It won't tighten down. But this is carbon. They say don't touch it with your fingers. Me being a technician, I had to try it. It worked. I don't know if it's still working, but I did it. But they say don't do it. Just those 2 little pins right there is where you would put your meter. Put each lead on there and just watch it. You're going to see maybe 13, 14 microamps or volts DC. Here's what we're looking for in the gas ratios on a positive pressure boiler. 10 inches of water column coming in. Your air pressure 1.4 inches. Your manifold 3.5. Okay, you got that? Now remember, you need the 1/4 inch flame lift off because that burner tube is made of stainless steel alloy and does not take direct heat at all. It can't handle it. When you're checking the air pressure on these boilers, if you put the panels back on the front and run the hose through where the filter is, you may get 0.2 or 0.3 increase in water column. inches of water column. It's not necessary. Analysis twice a year, just to see where it's at. You don't have to do it every year, but if you know in the springtime or summertime, if you put your analyzer in there and your gas settings are one way, and you go back like a morning like today, it's nice and cool. It's been dry here lately. My skin's telling me we don't have our humidity. Put the analyzer in there and see the differences in them between the two seasons. Yeah, it may surprise you. In Austin, once a year, they don't get the humidity that we get here. Same thing with Dallas. So this is something, air density, when the temperatures outside change, it may change your settings on your boiler. It's a good idea to try to check them for the customer. This is another problem, air filters. Man, we can't get these people to check their air filters. You know, you may still set your 1.4 inches on your air proving switch, but that's going to change your combustion. So it's supposed to be blue. You can see where it's blue. Those are horsehair. With the exception of the box ones that you'll see on your hydronic, those are MERV 8. We don't want to go above MERV 8 because that will also change your settings too. You start slowing. You get too restrictive on the air. This is what happens whenever you get the fire or the heat gets too close to the burner. If you look inside of one of those portholes and you start seeing ribbons of orange, okay, whether it's if you're looking up at it and you start seeing the ribbons of orange come off the burner, or if it's like this here, the burners are this way and you're seeing it go up, this is what's happening. It's cracked. You see where all the heat got to it, right around here, and it'll crack these burners. And what you're going to be doing is sooting that heat exchanger. You're going to be sooting it like you can't imagine. The more soot you put out and we start closing off those fins, the less that boiler is going to be removing, the water is going to be removing the heat from that heat exchanger. Then you're going to get to this right here. Now keep in mind, if you have to pull burners, see that gasket right there? That's all this. Whenever you start trying to pull them out like that, you're going to rip that gasket. So you're eventually going to pull the whole boiler apart. Instead of changing the burners, you're going to pull everything. The orifices, manifold, you're going to pull all of it apart. When you're at that point, you may as well get in there and look at that heat exchanger, pull the panels off of it, see if you can't rinse it out. Because you get here, you've sooted a heat exchanger. Then you're going to get to here, it's going to blow the tips clean off of them. At this point, you're going to look in there and you're going to start seeing a big swirl. It's going to look like a hurricane turning in there. Okay, just a big orange blob. And all you're doing is just blasting gas.
Hey, your filters on your couple slides ago, are those washables or replaceable?
Yes, yeah, that's a horsehair filter. You can pull it out, rinse it off, shake it out, kind of pat it dry and put it right back in.
Okay.
They're horsehair. They're real coarse. So yes, you can. So when you get to the heat, when you soot a heat exchanger, that's what's going to happen. Me and Jason pulled this heat exchanger out. We've actually ended up pulling the whole boiler out. As you can see right here, you can see where the soot, you can see where the burners were, right here. You see all that right there in the bottom? That's all soot. I reached in there and grabbed a whole handful of it. This is the one where the plumbers came in and put a brand new gas regulator in it. Did not set combustion, didn't set gas pressure, didn't set anything. They probably had about 14, 15 inches going into that burner, or into the gas valve. Luckily, I mean, I'm surprised the gas valve didn't blow, because that happens pretty regularly. We recommend whenever you put a gas regulator in, back that spring all the way out before you put the gas to it, so that the minimum amount of pressure is going into the gas valve in the boiler. So whenever we come in and do a startup, we can set the gas to the boiler. We were at the True Hotel by Hilton over in Katy a couple weeks ago. They had 17 inches coming in to the gas valves in the boiler and blew both the diaphragms out in the gas valve. Hadn't even got to start the boiler yet, and they blew them up. So that's something to keep in mind if you're going to be installing gas regulators, vacuum springs out. Make sure you're not shooting just a good hard pressure into the boiler. A lot of times on rate packs, they're green. Now, if you've got a sooted heat exchanger or an externally clogged heat exchanger, that heat's going to go around it. It's not going to go through it like it's supposed to and go out the stack. You see where the bubbles were, where it just got so hot. This is hot pink. This is a bright pink area on ray packs because that heat goes around them. And again, if you walk up to a boiler and touch it and you can't, then that heat's not traveling through that heat exchanger, okay? The exchange of heat from the water, from the flame to the water is not happening either. So you take a chance on melting that heat exchanger, if you aren't careful.
You usually feel it when you walk in the room.
Yes.
It's hot.
Yeah, you open the boiler room door and it's wham, that heat hits you, it's not going out the stack. Sequence of operation, your demand light, your operator light is on, make sure the high limit's not tripped. Your safety circuits, your water flow and your airflow, your ignition cycle is your hot surface igniter at 3.2 amps. Your ignition module is powered at 24 volts. Your flame rectification, flame sensor is greater than 1 microamp. Make sure the gas valve's open and discharging the pressure. You should have a nice blue flame across the tray. In your manuals that you've got there, this is just a couple of things that are in there. This is an electrical guide to help you. You guys know as well as I do, if you start chasing electrical problems, man, you can go all day long. Just like little ghosts. This just gives you an idea of things to look for in the boilers, in the RAPAC boilers for electrical issues. And then a little dumb-me-down troubleshooting guide. Is the power on? Literally, that's what the first one says, is have electricity. So, just some of the tools that you need. You guys already have these. Some visible checks that we like to talk about. Your pressure relief valves. If you have a pressure relief valve leaking, dripping, replace it immediately, because the state inspector is going to walk in and turn around and walk right back out. He's not going to go any further. Okay. This is one we like to point out. That bulb needs to be a little bit closer to the water. You're going to get residual heat, but it's not going to be up. You're not going to get an actual true reading because there's your bulb. You got all that copper between it. So, common sense. Man, we run into places that have no common sense whatsoever. Another thing too is you see this, that's a leak. Anytime you see that white buildup on a pipe, you go over and somebody scratches it, 140-degree water will hit them in the face if they ain't careful. It's calcium. Calcium's gonna seal a leak. So if you start seeing stuff like that, be aware as far as replacing it. This is one of the things that I pulled out of this right here. This is all your safety circuits. You got your manual high limit, your block vent, your low gas pressure, high gas pressure, your auto limit, and then this. You guys deal with a lot of reverse polarity when working on systems? Have y'all seen reverse polarity?
At times, yes.
Okay. We do.
Some of our sensors are actually polarity sensitive. And they'll be actually a dual purpose sensor where one facet of the sensor is indiscriminate and where the other half is. So, I mean, we're aware of it.
Gotcha. Well, RAPAC boilers they're protected against reverse polarity. Again, at that True Hotel that we had the gas valve problem, they had two setups. They had a boiler switch, a pump switch, a boiler switch, and a pump switch, and they had a neutral tied in to power, and they were feeding. He had 83 volts on the neutral to both boilers. Now I hit the power switch, and the pump comes on, and the fan comes on, and it went no further. It just sat there and did nothing. So I'm like, okay, there's some, I know what that is. Pull the meter out, bam. I've got reverse polarity. The boiler won't do anything, the pump and the fan will run, it'll run all day long. And it won't give you a signal, okay? It won't give you a red light or nothing. It just won't go past that point of the fan. So reverse polarity is very important to check for. If you kick the power switch on and it doesn't do anything but run those two, then you know you need to check it. I've gotten in the habit of checking it anyway, especially when there's contractors involved. I mean, you could really tell these were not very good contractors, but it ended up happening. So reverse polarity is an issue. This is a very good schematic of the board. I'm not an electrician at all. That shit scares me. Sorry, but yeah, I just can't. But I've had to do it. I've had to get out there and learn this thing because they said, you know, get out there and troubleshoot this. And this is actually a very good, easy one to read. And I've actually gotten pretty good at it. I've gotten better. It don't scare me as much. On the electrical side, 120 volts, check your amperage, that's your hot surface igniter, and then of course check for polarity. Troubleshooting is trust but verify. You know, Jason and I have known each other for over 20 years, but if he tells me he killed the power, the first thing that comes out of my bag is my meter, you know. So trust but verify, visible checks, isolate based on the sequence. If you know that sequence, then you know whatever's running. If it's not running from that point on, is where you need to start checking. Follow the voltage, adjust, repair, replacement, of course, perform a startup before completion. Here's some of the common issues you'll see. Bad igniter. Now there's still spark igniters out there. Kind of rare. RBI still has them. You may run across some an old atmospheric that still has a spark igniter. It's a straight rod with a bent rod, and it sparks between them. As they get hot and cold, they'll expand and contract, and eventually the gap widens, and you'll still hear a click, 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 but it won't be, you won't actually be sparking. So keep that in mind. But your polarity, low gas volume, low gas pressure, that's just your manometer checking that. Dirty filter, faulty part. Faulty part would be a flow switch, air proving switch, hot surface igniter, flame sensor. Those things are going to go down on you. They're not made to last forever. Plugged heat exchanger. We talked about the external plugging, but what about internal? Internal caused by calcium or restriction in flow. When you hit the power button on that boiler and that pump starts and it lights, it's going to dance off the foundation at you. You're going to start hearing a banging, pow, 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 and it'll just vibrate, boom, boom, boom. You've got an internal plugging on a tube. Okay, that's the key. That's what's going to let you know that you've got a restriction. Now, we had one in North Houston that did that. It was a 989. It was about this long, and it took 3 weeks to plug that whole tube because they had the cold water going into the boiler first. They had it plumbed like I told them, don't do that, but they did. So as it builds up and started plugging that tube off, whenever they kicked the pump on and the water would come in and hammer that spot, bam, 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 the boiler would dance. But as we pulled the head off of it and looked in there, that tube started rolling up. It actually started pushing the tube out of the head. So if they had it running and it was doing that and it pushed that tube out and those burners were lit, it was gonna cause havoc. It could cause flashing. You know that steam, whenever you're dealing with steam, one drop of water will flash into steam and will fill a 3 foot by 3 foot box. It expands 1,600 times. So when you're talking about a volume of water, that big around, a good stream, steady stream of, maybe 40, 50 GPM, going in and hitting 15, this is 15 burners on a, so you hit 15 burners, that water's gonna flash. Not all of it, most of it. It's gonna go somewhere. So those panels were gonna come off the side of it, I would suspect. So if you start hearing that banging whenever you fire a boiler up, you've got internal plugging. You feel the heat on the boiler, on the outside of the boiler, or in the room like we talked about, that's the external. You got leaking. Is it leaking or is it condensing? Because we've had that problem too, where people say my heat exchanger is bad. We pull the heat exchanger, I do a hydro on it, it's fine. Then we get to looking at the system temperature coming back was 97 degrees, and it was raining. It was just water was pouring out of that boiler. And we also noticed it because I looked down in the burner area, you could see where the condensate was running down the tubes. So be sure if they tell you, if they say that their boiler's leaking, make sure look at the system. What type of system is it? You being in a hydronic, it could be a plugged vent or a plugged drain, and it's causing that boiler to run water out of the side of it because you're dealing with a lot of condensate. You get in some of these hydronic systems where your water temperature is coming back at 60 degrees, man, that boiler's raining. So we have, our boilers are safe to have water coming back at 50 degrees. So low flow is a killer. This is where the pressure gauges come into handy. They'll let you know what the pressure, if that pressure starts changing inside of that boiler, you start slowing that flow down. Now in a hydronic system, you're dealing with a closed loop. So you have closed loop treatment, usually a nitrite, sodium nitrite. So you're not dealing with a whole lot of water makeup. It should be a closed loop. It should be tight. But some instances it's not. But that low flow through that boiler, you're going to start heating that heat exchanger up. You're going to hit high limit temperature if you aren't careful. So any type of restrictions, low flow, that's a killer for boilers. Pressure chamber leak, talked about those gaskets on that pressure chamber. If the chamber's leaking, it's not going to like that boiler. You're not going to meet the air pressure demand inside the chamber. Gas valve off, of course. Sooted flame rod. Those flame rods can be pulled and cleaned. And you can take them out, take a dry cloth, and just wipe them off. Don't use any sandpaper, or you can use just a mild Scotch-Brite. But you don't want to score the surface too bad. You just want to wipe it off. You should put it back in and it should be fine. Cracked igniter, that goes without saying, it ain't gonna light. So just replace it. And then of course no hot water at the fixtures, the boiler's working fine. We do maintenance schedules. I don't know if you guys help with your customers as far as giving them maintenance schedules, things to look for. Not necessarily to work on the boiler, but things to look for on a daily basis. We also do it on a monthly basis, just things to check for. We try and get the customers involved. You know, get them, because they'll walk by a boiler room and never even walk into it and look at it. So we offer these here that can help you out as far as a daily, a monthly, and then we do have the annual to help out with if y'all do annual. Do y'all do annuals on the boilers? Y'all do?
We have that. I don't know.
Okay.
We have, we've just been using some boiler company.
Oh, okay, so you're not necessarily worried about it. But it gives you everything, lists everything that needs to be done on an annual if y'all are wanting to do it. Any questions? Let's go into TDLR, Texas Department of License and Regulations. Carbon monoxide detector will lock them out, and they're not automatic reset. They're manual. And Rob Trout said the reason I want that is I want them walking in that room and pushing that reset button and find out why it tripped. Carbon monoxide detector, like I said, interlocks with 2, the expansion board does 3. Here's the rule for the single opening and double opening. Now you notice in all the new schools, they'll have an opening that's 12 inches off of the ceiling and 12 inches off of the floor. If they have a louver in a door, which you see a lot of, the opening shall be sized based on 1 square inch of free area for every 2,000 BTU. This is combined BTU. If you have 4 boilers in that room, you take all the BTUs, add them up, and you divide it by 2,000. That's going to give you the square inches that's needed, okay, to be legal. If you have a 2 opening, like I said, the 2, 1 off the floor and 1 off the ceiling, it's for every 3,000 BTU. So they give you a 1,000 BTU leeway for having the 2 openings. Okay. If the power ventilator or fan, it's 0.2 CFM for each 1,000 BTU fuel input and the combined burners. The boilers and fans shall be interlocked so that the burners will not operate unless the supply combustion ventilation dilution air as required by the boiler manufacturer recommended. What it means is you can do a pressure switch. That boiler will not, whenever that fan comes on, sets the pressure switch, the boilers will light. If for any reason that pressure switch falls, the fan shuts off, it locks the boilers out. Okay. Here's the kicker. There's always one of those big brothers always going to throw a little wrench in the spokes. For a 1 million BTU water heater, 1 square inch per 2,000, you need 500 square inches. So if you have a 24 by 48 louver, you've got 1,152 square inches. But because of the louvers that's in that, it's only rated at 50%.
That's not free area.
Sorry?
It's not free area.
No, sir. No, sir. So 1,152 square inches is rated at 50%. You only have 576, which are still legal. You only need 500. You don't need 501. Keep in mind, if they have louvers, you're rated at 50%. But if for some reason they have a mesh on the back of that louver to keep bugs out, it cuts that by half. You take that 576 and slash it by 50%. Now you're not legal. You can take that mesh off and get back up to 576, you'll be okay. But anytime you add mesh or a filter or anything over the top of that louver, you cut the square inches from that 50 by another 50. Okay?
Yeah, when I went to school 50 years ago, it was 1 square inch per 1,000 BTUs.
It was. Input. Okay. See, atmospheric, that was mainly for combustion.
Right.
Because you're talking about combustion air because it's an atmospheric boiler. It doesn't have a fan assist or anything like that. So
We didn't have things back then.
the paper ones.
Yeah.
At church.
Exactly. So anyway, this is here's the carbon monoxide detector. We actually sell one, and there's somebody else around town that sells one. The thing is they have to be calibrated every year, and the calibration costs almost as much as a brand new unit. And to find somebody that's certified to calibrate them, it's very hard, and it's expensive. It's expensive to calibrate them. So I've gone as far as tell people just buy a new damn unit. Put it on, you got it all wired up, you get another year out of it. But they want, they've actually talked to me about going to school and learning to calibrate them. I just hadn't had time. I'd like to do it, but I think it'd be more trouble than what it's worth, because they say it's not easy to calibrate them, and it's timely. Carbon monoxide. This is something that's very near and dear to us because we almost lost somebody. We almost lost one of our engineers. I don't know if y'all know Calvin Timmons. Maybe you've heard of him. He's our applications engineer. Extremely smart. Was in a boiler room for 31 minutes. Had a gentleman with him that was 81 years old. Luckily, Tom kept getting called out of his room. He had his on his phone, and he would go in the room and he'd turn and he'd go back out. He spent the majority of his time out of the room. Calvin was in there for 31 minutes. The maximum allowable in the blood is 100 parts. He had almost 900 in his blood. They said 13 more minutes it would kill him. He fell asleep, never woke up. Carbon monoxide is odorless, colorless, tasteless. You don't know it's there. Now, since coming aboard, well, since all of that happened, this is the sales pitch of the whole, and that's a personal carbon monoxide detector. Trey Wilbanks said, okay, you guys are going to carry these from now on. You're not going to go anywhere without them. Don't let me catch you without them. I actually saved 3 women's lives with this, and it saved me a couple of times. I've been exposed to it. So, $160, my life's worth it. I got 5 kids, 5 grandkids that I love very much, and so that keeps me on.
To calibrate that.
This one is it automatically calibrates. So anytime you turn it off and turn it back on, it calibrates itself. It's a two-year battery. Mine lasted a little longer than 2 years because I turned it off on the weekends. They say continuous use, leaving it on 2 years. But the things that happen with carbon monoxide, there's a lot of things. You can get impaired vision, muscle cramps, nausea, and the headache I had from being exposed to it was I've been shot. So I know what pain is. That headache I had was almost as bad as being shot. And it was a 2-day headache, and there was nothing for it. Nothing you can do for it, other than going to the hospital and getting pure oxygen. So, and turning the lights off, aspirin, all that, didn't do anything for it. My eyebrows hurt. That's how bad it was. My eyebrows were just, I was painful. So, a lot of times you go into a mechanical room, I know you guys deal with a lot of refrigerant. I don't know if they have refrigerant monitors in the rooms. Well, a lot of boiler rooms don't have carbon monoxide detectors, not unless they have to have them by law because they don't have enough ventilation. So even in a boiler room, it doesn't have to be a boiler room. Me and I were at a Japanese restaurant eating, and it had 67 parts of carbon monoxide where we were eating. So us being inclined and people that feel like we need to tell somebody, I told the manager, if your cooks are having headaches or they're feeling sick, or you think they're being lazy, they're not. You're exposing them to carbon monoxide. They need to go outside and take breaks. I went into an apartment complex office, brand new, nice, 197 parts of carbon monoxide.